My name is Siti Nur Farzanah, but you can call me Far. So let me introduce you to my team members. So this is Puchi Dini.
Hi, they call me Binti.
Next, we have Irina.
And the full name is Nuragina Patricia Binti.
Yeah, she's quite shy.
Yes, apparently yes.
So this is Husna. She loves being independent.
Hi guys, my name is Husna Farah with Nafiqaha, but I prefer you guys call me Husna.
Lastly, we have Ain.
My name is La'an Binti Muhammad. You guys can call me Ain or Akila.
Shazwan has a piece of land with a market value of 80,000 ringgit Malaysia. He can either sell it now and invest in a fund which offers 5% interest compounded quarterly, or to sell after 8 years at 110,000 ringgit Malaysia. Which option gives a better return? Justify your advice. Based on the question, we can create a summary that Shazwan owns a land worth 80,000 ringgit Malaysia right now. Shazwan was given two options, which is to sell the land now for 80,000 ringgit Malaysia. Another option is to sell the land after 8 years. Therefore, we have to decide which option gives more money after 8 years. Here, we know that after 8 years, the amount accumulated if Shazwan sells the land is 100,000 ringgit Malaysia. So, we have to calculate the accumulated amount if Shazwan sells the land right now. We will use the formula S equal to P in bracket 1 plus K over M in the power of N. S equal to 80,000 ringgit Malaysia in bracket 1 plus 0.05 over 4 with in the power of 32. How do we get 32? Because it is the amount we get after we multiply 8 by 4. The amount we get after use the formula is 119,050.44 cents ringgit Malaysia. Therefore, Shazwan should sell the land right now because it holds more value than if he sell it after 8 years.
Okay, so for question 2, the question says Tina deposits RM1,000 into an account that pays 5.2% interest compounded every 6 months. After 4.5 years, she makes another deposit, and we need to find the value of the second deposit if she wants the account to be worth RM8,000 7 years after the second deposit. So here, I made a summary to help understand the situation. First deposit is 1,000 ringgit, and interest rate is 5.2% per year. It's compounded every 6 months. The second deposit is made 4.5 years later, and after another 7 years, the total should be RM8,000. Our goal is to find how much the second deposit must be. And we are using the compound interest formula, which is S equal to P bracket 1 plus I, close bracket, to the power of N. Next, I calculate the future value of the first deposit. So these are the formula. I divided the 5.2% by 2 because the interest is compounded every 6 months, and 2 multiply 4.5 gives us the number of compounding periods, which is 9. After calculating everything, the first deposit grows to 1,259.87. So this amount represents the value of the first deposit just before the second deposit is made, like 4. Now, I move to the second deposit. Here, the final total needs to be RM8,000. So I let the value of the second deposit be X. Using the same formula, I use 7 years because that is how long the second deposit will grow. After simplifying, I get 8,000 total 1.4323X. And so before subtracting anything, the total value contributed by the second deposit needs to be X equal to RM 5,585 ringgit and 5 cents. But this RM 5,585 and 5 cents is the total amount needed, including the value of the first deposit. So to get the actual amount, Dina must deposit the second time. I subtract the first deposit's future value, which is I minus the 5,585.5 with 1,259.87 equal to RM 4,325 and 80 cents.
Malik invests 35,000 ringgit into an account at an interest rate of K% compounded monthly. After 6 years, the account balance is 51,639 ringgit 95 cents. Question A asks, interest rate K% that is compounded monthly. To find the interest rate, we need to use the formula that is given. First, we need to take the account balance after 6 years, which is 51,639 ringgit 95 cents at S, and then 35,000 ringgit at P. We are trying to find K, so we will not put anything there. Next, we will put 12 at M and 6 at T. And then we calculate, and then we will get 6.5% of interest rate that is compounded monthly. Question B asks, the total amount of the investment was extended for another 4 years. For this question, we need to use the exact same formula as question A, but change the T to 10 years. And then the answer will be 66,926.43 cents. And then for question C, they ask the total interest earned for 10 years. we need to take the answer from question B, which is 66,926 ringgit 43 cent, and then subtract with the amount that Malik has invested 10 years ago, which is 35,000, which makes the answer is 31,926 ringgit and 43 cent.
Question 4. An executive traded his car for 35,000 ringgit and topped it up with his savings of 4,000 ringgit to buy a new car. The new car is listed at 96,000 ringgit. He obtained a loan from a finance company to settle the balance of the purchase price. He has agreed to settle the loan by the monthly payment to be made at the end of each month for 9 years. The interest of the loan is 10% compounded monthly. Question A. Find the monthly payment. Formula is A equal to R, open bracket, 1 minus, open bracket, 1 plus I, close bracket, power minus N over I, close bracket. The solution is 57,000 equal to R, open bracket, 1 minus, open bracket, 1 plus 0.10, close bracket, power minus 108 over 0.10 over 12, close bracket, and you will get 71.02935491 R. And you need to do 57,000 over 71.02935491, and we get the answer are 802 ringgit 49 cents. Question B. Calculate the interest charge. Formula is I equal to NR minus A. I equal to 108, open bracket, 802 ringgit 49 cents, close bracket, minus 57,000, and we get the answer RM 29,968 ringgit 92 cents. Question C. Immediately after paying the 70 payment, he decided to settle the balance of the loan. Find the balance. The formula is AN equal to R, open bracket, 1 minus, open bracket, 1 plus I, close bracket, power minus N over I, close bracket. To get the N, you need to do 108 minus 70, and we get 38. The solution is A 38 equal to 102.49 cents, open bracket, 1 minus, open bracket, 1 plus 0.10 over 12, close bracket, power minus 38 over 0.10 over 12, close bracket, and we get the answer is RM 36,045 ringgit 92 cents. Question D. If he fails to pay the first 6 monthly payments, find the amount he has to pay on the 7th payment in order to settle the outstanding areas. I is 0.10 over 12, N is 7, R is 802 ringgit 49 cents. Formula is SN equal to R, open bracket, 1 plus I, close bracket, power N minus 1 over I, close bracket. The solution is S7 equal to 802 ringgit 49 cents, open bracket, 1 plus 0.10 over 12, close bracket, power 7 minus 1 over 0.10 over 12, close bracket, and the answer you will get is 102,058 ringgit 63 cents.
And I will explain about the question 5. So the question is, NNZ Constructions buy a machine costing RM 500,000. The company pays a 15% down payments, and the balance will be repeated through quarterly payments of RM 2,000 starting 3 months after the purchase. The financing carries an interest rate of 9% compounded quarterly. We need to find how many years are required for the loan to be fully settled. First, I calculate the total amount of the down payment, 100,000 times with 50% equals to RM 75,000. So the down payment is RM 75,000. Next, I find the amount of the loan, RM 500,000 minus with 75,000 equals to RM 425,000. So the loan the company needs to settle is RM 425,000. 425,000 equals to 20,000 bracket 1 minus bracket 1 plus 0.09 divided with 4, close the bracket, power with negative n, close the bracket, and divide with 0.09 divided with 4. Then, simplify the equation step by step until it becomes 221.25 equals with bracket 1 minus bracket 1 plus 0.09 divided with 4, close the bracket, with power of negative n, close the bracket, and divide with 0.09 divided with 4. And then you will get 0.478125 equals with 1 minus bracket 1 plus 0.09 divided with 4, and with the power of negative n. We need to solving for n, so move the terms. 1 plus 0.09 divided with 4 with the power of negative n equals to 0.521875. Then I take the log of both sides. Log bracket 1 plus 0.09 divided with 4, close the bracket, and with the power of negative n equals to log bracket 0.521875 and close the bracket. Bring the power down. Negative n with the bracket of 0.00966331667 and close the bracket equals to negative 0.2824335072. 229.2274 equals to 40. So T equals to 7.31.